Hey guys, once again welcome to our channel. In today's video we are going to discuss about diffusion in more detail. We are going to explain diffusion more briefly, and also we are going to cover all of the latest concepts of the chapter 1, particular nature of matter. So without wasting our precious time, let us get started. Now before we move on to diffusion, we'd like to jump into the syllabus first so we can see have we already completed all the syllabus for concept 1, the chapter 1, particular nature of matter. We have cleared all the concepts and we are left with no doubts. Let us see to it. Yeah, so here you can see the syllabus and almost we are done. Just we are left with, I think the last, you can see here where my arrow is pointing. Describe and explain dependence of rate of diffusion on molar mass or molecular mass. This you have to show, and then we are also going to explain and describe diffusion more briefly in more detail. So let us get started. So firstly, talking about Brownian motion, let's recall what is Brownian motion. Now as before we saw what is the definition of Brownian motion. Let me just give you the example we were talking about. Firstly, just let's see to the slide. Explanation and evidence for Brownian motion. An example of Brownian motion is the observed jerky and erratic motion of smoke particles as they are hit by the unseen molecules in the air, which can be seen under a microscope. In 1905, physicist Albert Einstein explained that pollen grains in water were being moved by individual water molecules. In all cases, larger and visible particles are caused to move by the random bombardment of smaller invisible particles. So, if you remember, if you've watched my previous video, you remember me saying that I was talking about a scientist who was observing a pollen grain suspended in water. And yes, I was talking about physicist Albert Einstein. So let me just recall that. Now what happened, this scientist was observing a pollen grain suspended in water, and he realized that pollen grain was actually constantly moving in random directions. This made the scientist wonder why the pollen grain was moving in this fashion, and he figured it out. Now, if you remember the kinetic theory of matter, now particles are always in constant motion. This meant that water molecules were actually bombarding the pollen grain in random directions to cause the sort of movement observed. Okay, and also I showed you one diagram. If you remember, you can watch the previous video, so your all doubts are clarified. Now, moving on to the definition of Brownian motion, let's recall the definition of Brownian motion. Now, Brownian motion is defined as the erratic, random movement of microscopic particles in a fluid, example as we talked about it, that is pollen, as a result of their continuous bombardment from molecules of the fluid, example water molecules. Now moving on, let's talk about diffusion and molecular mass. But before we jump into this part of the molecular mass and diffusion, how they're related, I would like to recall the definition of the diffusion. Now, what is diffusion? Diffusion is the net movement of particles from a region of their high concentration to a region of their lower concentration down a concentration gradient. Now, the constant random movement of particles and their kinetic energy allows diffusion to occur. Ultimately, this means that particles will spread out from one place to another. Now, we are clear with the concept of the definition of diffusion. We have recalled each and everything. Now let's talk about this now. Diffusion occurs much faster in gases than in liquids, as gaseous particles move much quicker than liquid particles. Yeah, it's a fact, gaseous particles, because they are arranged in random, they move randomly, they are arranged widely spaced, they are too much widely spaced, whereas liquids, they are close together but an irregular and unfixed pattern. So we can see that diffusion occurs much faster in gases than in liquids. Why this happens? Because gaseous particles move much quicker, their movement is much quicker than the liquid particles. At the same temperature, different gases do not diffuse at the same rate. Okay, this is due to the difference in their relative molecular masses. Lighter gas particles can travel faster and hence further. Therefore, the lower its relative mass, the faster a gas will diffuse. Now what happens, now there are many things that can affect the rate of diffusion, and as we're talking about the molecular mass, it is one of these things. Heavier molecules will travel slower than lighter molecules. In other words, the higher the molecular mass, the slower the rate of diffusion. I hope you are getting me. Now, if we move on to our next slide, you can see a diagram here, a representative diagram. Now you can see here we have NH3 ammonia on the left side and HCl on the right side. Now what happens if you know about your periodic table, you can see the mass numbers and the atomic numbers on the downside and the mass numbers on the upper side. Now you can see here, if you compare the molar mass of ammonia and hydrochloric acid, what happens? You get the result that ammonia has a lower mass than the hydrochloric acid. Now what happens if you leave them in this closed tube? Okay, if you leave them in a closed tube with no source of air or anything, now what happens? This ammonia has a lower molar mass. So as we discussed the point before, that lighter gas particles can travel faster and hence further. Now you can see here this ammonia is lighter in mass, so it's traveling faster and hence further as compared to hydrochloric acid. Now what happened? This ammonia will diffuse faster than hydrochloric acid because it's lighter, and it will react with HCl, the hydrochloric acid, making the product of ammonium chloride closer to the hydrochloric acid end of the tube. Now what happens if you see here, if you see the last tube, you can see here this white product is formed, but it's formed near hydrochloric acid. Why? Because this ammonia was lighter in mass. Okay, so it has traveled faster and hence further, whereas this hydrochloric acid was heavier in mass, so it's traveled the least. Okay, and this means the product, the white precipitate or the white product, will be formed near the hydrochloric acid. Okay, so you can see here the conclusion. NH3 molecules have a less mass than HCl molecules, so diffuse faster. Hence, the product, a white cloud of ammonium chloride, NH4Cl, forms closer to the end where the HCl is. This is the end of our video. I hope you didn't have any questions in the mid of the video, starting of the video, end of the video. I hope this will help you a lot if you are preparing for the upcoming October-November series, or if you are planning for IGCSEs. If someone has shift from grade 8 to grade 9 to grade 10, I hope this will help you a lot. Start following this. But before, please like this video, hit the like button, subscribe my channel, share this video, comment down below, and stay tuned for the upcoming videos. Thank you and have a great day.